Hi, welcome back. Let's continue our discussion on partial derivatives. So we're given a function f of x y equals x squared plus 4x plus y squared minus 8y plus 16. That's a mouthful. We want to find the partial derivative with respect to x. Now again, if you don't like this notation, you can use del f over del x. Again, that's called little del or f or little d. And when we take the derivative with respect to x, we only care about the parts with the x's, nothing with the y. So we should just get 2x plus 4. And if I'm looking for the partial with respect to y, remember this is saying I want the partial derivative, this is what it says, with respect to y. And that's just going to become 2y minus 8, because I don't care about the x's, just those two. 4, 16 left all alone. The next thing we want to do is we want to find out where they're both equal to 0. So if I want to find out where the partial of x is equal to 0, I can just set that part equal to 0. So I get 2x plus 4 equals 0, or x equals negative 2. So what does this mean for us? Well, what this says is at x equals negative 2, the function has 0 change or 0 slope in the x direction. That's what that's telling us. So it's kind of like if you're on a hill, right? You're not changing anywhere on the x direction. What about the partial with respect to y? Whoops, xy. Well, I just set my y part equal to 0. 2y minus 8 equals 0, or y is 4. And again, just like the partial with respect to x, at y equals 4, the function has a 0 slope, or has 0 change in the y direction. Now, it's not always going to be x, it's not always going to be y for those. It could be a combination of different answers as well. This is just how this problem worked out. All right, so the next question says, write the equation of a tangent plane. And this is really kind of a neat little problem. So let's imagine our egoid of mathematics represents our surface. And this index card, which has all of our trig rules on it, hoorah, I still have mine, do you have yours? Represents a plane. Well, we are trying to find the equation of the tangent plane at this point, 0, 0. So, well, in other words, 0, 0, I can put a plane on there, and it's going to touch that egoid of mathematics in one exact spot. We're going to find the equation of that tangent plane right there. Now, we've done tangent planes before. The two things we need, one, we need a point, and of course we need direction. So the first, ignore this for now. That's just ignore all this stuff right there. That's just something else. Don't worry about those. So the first thing we're going to need is a point. Well, to get the point, we want to be at 0. So we're going to use the point 0, 0. So just for, they'll always tell you the point. I just scratched it out. So if I plug 0, 0 into my function, go up here, 0 plus 0 plus 0 minus 0 plus 16. So that's just going to become 16. So we would have the point 0, 0, 16. So there's our point. Next, we need to find the slope, or our direction vector, directions, the slope, in other words. Well, how do we get the slope? Well, we need the slope in the x direction and the slope in the y direction. So the slope in the x direction at 0, 0. Let's see here. If I plug x in here, so if I plug it in, if I plug x in here, I would get 0 plus 4, which is 4. Find the slope in the y direction, 0 at 0, 0. Plug in here, we would get negative 8. So we have our slopes. So this is the slope at that point in the x direction. And here is the slope at that point 0, 0 in the y direction. So to get our equation, we're going to use something very similar to what we did last year. Y minus y1 equals mx minus x1. But if we're going to extend that to multiple variables. The slope just means I want the slope in the x direction. So I could write this as z minus 16, my point, equals, let's look at the change in x's, 4x minus my point, 0, plus my change in my y, my slope in my y direction, negative 8, y minus 0. And so this would be the equation of our tangent plane. Of course, we can simplify this. Z minus 16 equals 4x minus 8y. Or we can say z minus, or let's do it the other way, 4x minus 8y minus z equal to 16. I can write it that way. But if I want to use this for a plane estimation, I could say let z equal 4x minus 8y plus 16. And this is the way we typically would write it, because we want to write the plane in terms of z. So what that means is now, any point near my tangent plane, I could estimate the value. Like if I want to find the value here, I could estimate it. So for example, I can now estimate the value at, let's say, the point 0.1, and I want to estimate what that z value is going to be. I could plug that in. Z would be about 4 times 0.1 plus 8, minus 8 times 0.1 plus 16, or 0.4 minus 0.8 plus 16, whatever that is. And that would be my estimated value. Very similar to what we did last year with tangent line approximation. All right. Hope you guys enjoyed the video, and I'll see you guys later. Bye-bye.